Professional remote management of multiple Jetson devices can be quite a challenge. Fortunately, there is software and hardware that can help. Hello, it's Jim from JetsonX.com. There are two distinct methods for monitoring and managing devices and systems remotely. You are probably familiar with the first. When we connect to a remote computer via SSH over a network connection, we are doing in-band management. In-band management depends on the operating system. It requires the OS to be functional for management tasks. There's a shared network channel. It utilizes the same network infrastructure as regular data traffic, integrating with existing network tools. This is all routine administration, suitable for everyday management tasks such as monitoring, updates, and service management, but limited during failures. The second method is out-of-band management. It's independent of the operating system. It operates independently, allowing access even if the OS is down. There's a dedicated management channel. It uses a separate channel for management tasks, enhancing security and reliability. This method provides access during failures. It provides management capabilities during system or network failures, crucial for troubleshooting and recovery. Today, we are looking at the Allxon Bolt Out-of-Band Enabler and RMM portal for NVIDIA Jetson. The RMM portal will handle both in-band and out-of-band software management. You will need to add the Bolt hardware to enable out-of-band management. Let's take a look at the Bolt hardware. You can see that the card is about a quarter of the size of the Jetson, and there's a mounting bracket. This is a standard one-slot size. The Bolt connects to the Jetson using 9 wires. 3 go to the GPIO pins, 6 go to the automation header. Let's zoom in a little bit. You can see the automation header pins are underneath the Jetson module. You can connect the Bolt to the network through either the Ethernet port or through the built-in wireless. You can supply power to the Bolt using a micro USB cable. Looking at the wiring diagram, we can see how the Bolt controls the Jetson through the automation header. The Bolt can control power on, off, and reset on the Jetson through the automation header pins and has direct access to the serial debug console. The Bolt has access to another UART along with using pin 5 as a power monitor on the GPIO pins. After wiring up the Jetson, we will install the Allxon Agent. We'll scroll down the page a bit here. Let's grab our command. Now we'll run it. Password. After installation, the agent window will pop up. Let's grab our pairing code so that we can add this device to our monitoring software. Oh no, I only have 10 minutes to set it up. On the Jetson, that's all we need to do. You need to have an account to sign into the portal. You can get a free trial. Let's sign in real quick. The website is well organized. There are built-in tours to help you get started. Okay, let's add our device to the portal. We click the Add Device button, Edge Device. Next. Now we enter in our pairing code. Next. Congratulations! Then we hit Done. Our device has been added to the portal. Let's open up our device. The Overview tab gives us a general look at how the device is performing. It gives us a very detailed view of the device. This includes information such as the network address, hardware UUIDs, memory usage, temperature, drive space, everything you gots to know. You can also get your device logs. Let's take a screenshot. Press Execute. And about 8 seconds later, we get our screenshot. As you recall, some of the Bolt enabler lines were tied into the power management on the automation header. That gives you hardware control of being able to turn the machine on and off, reboot, and so on. Let's switch off the Jetson. We get a notification that it's finished. Now we switch it back on. And we get our notification that it's back on. Let's switch over to the Serial Console tab, and we'll open up a session. Remember, we are on the Serial Debug console because we are using the Bolt Enabler. This is a secure channel. Let's log in. And we are ready to go. And here's where we are different from in-band management. Let's reboot the Jetson from the command line. It starts the familiar boot sequence. Now let's hit the escape key. And now we can enter into Setup or the Boot Manager menu. Let's go into Setup, and from here we can go into the Device Manager or the Boot Manager or the Boot Maintenance Manager. This gives basic access to the UEFI. Let's take a look at the Boot Manager. From here, we can choose which device we want to boot from. This is an extremely valuable tool to have in the toolkit, which only comes with out-of-band management. Let's exit out of this. Let's go over into the Device Manager. And we can see all the Device Manager goodness. Let's get out of here and continue the boot process. A minute or so later, we're back at the login prompt. We can close the session by clicking the Close Session button. Allxon makes over-the-air updates easy. Let's go over an example. On the Jetson Hacks account on GitHub, there is a repository named Allxon OTA example. Let's clone that repository and switch over to that repository's directory. For our update, we will create a Python script that displays a window with an image on startup. Here's the image we will display, and here's the script to display it. We use the pillow library to display the image. We also create a service which will run the script at startup. Finally, we have the OTA_deploy script. The script describes how to create and install what is called an OTA artifact. These are comprehensive packages that support mass updates of various media types, firmware, drivers, containers, and image files, and so on. The artifact will be uploaded to the Jetson device for deployment. Looking at our script, we see that we install the Python package manager, Jetson stats so that we can use JTOP, and then our startup script and service. Now we will create the artifact and test it. We are doing this on a Jetson AGX Orin. Make sure you have an up-to-date version of the command line tool. We make the artifact. Now we deploy the artifact so that we can test. And then next we test it out to make sure it works. I say that rather casually. This can be quite the process in and of itself. Once tested, we can deploy the artifact. Now we go over to the portal on our development machine, then navigate to the over-the-air tab. We click the Upload Artifact button, then we drag and drop our artifact file. Now it is in the most beautiful color of all. Done. Now we are ready to deploy the artifact. There are all sorts of deployment strategies that you can implement. You can have groups of devices. The portal can support hundreds of devices. I have 2. Select the devices you want to deploy. Next. Now we click the Deploy button. You can see that it's processing. The processing time depends on the size of the payload. Installation complete. Let's reboot the device and see what happens. We're now on the device machine. It's an Orin Nano. Let's log in, and there's our startup window. Now we test JTOP. And now you know why you have to test the living daylights out of your update. Our script installed the JTOP service, but it did not include all of the users in the JTOP group. You need to be in the JTOP group in order to access JTOP. You can fix this from JTOP on the command line. This is almost always a problem. It's permissions. We make our change, quit, and reboot. Now, when we run JTOP, it works. Life is good. Before you send out an over-the-air update, make sure that you test it, thoroughly. In our case here, we would go back and modify the deploy script to include the user permissions. If you have a large deployment, keep a device or 2 locally for testing. If you have a group of Jetsons that you have to manage remotely, check out Allxon. Out-of-band management can get you out of a jam.